All right. Well, welcome everybody, and thank you for the January 2021 edition of the St. Louis Java Users Group. We've been meeting here remotely because of the pandemic. Just to tell people about our group, we're actually quite informal. Attendance is free. We don't have a formal membership list. Our normal meeting date is the second Thursday of every month except December when there is no meeting because of the holidays. When we meet in person, you can join us for food and social at 6, and we start the meeting at 6:30. When we do meet in person, and I'm still not sure exactly when that's going to be, we meet in the Object Computing Incorporated training room at 12,140 Woodcrest Executive Drive, Suite 310 in St. Louis, Missouri. I'd like to introduce the rest of the members of the steering committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Olspaw, that's me, Weiqi Gao, and Kathy Wang. You can reach all of us on the steering committee if you just send an email to that email address there at the bottom of the slide, javasigsc@ociweb.com. I'd like to thank our sponsors. Object Computing Incorporated is our original sponsor. They got us started right at the beginning. They sponsor our web hosting, and when we meet in person, they also sponsor the room location. JFrog is a new sponsor. They have been very generous to sponsor the fees so that we can have this Zoom set up, and they also sponsor the Meetup subscription. Signature Consultants and Adaptive Solutions are headhunters. So if you're looking for a position, I would encourage you to talk to them. When we meet in person, they sponsor the food. They alternate back and forth. JetBrains is also a sponsor. So at the end of this user group meeting, if you stay tuned, you'll be able to enter for a JetBrains license. Normally we raffle 2 JetBrains licenses, but this month we're going to have 4 because we did not meet during the month of uh, December, because we normally don't meet then, so we'll have 4. Elastic sponsors gift cards. We haven't figured out how to do that through email yet. Intertech sponsors the famous screaming flying monkeys that we give away. We'll figure out how to give away those as soon as we're back onto our normal meeting. We will have 2 Manning ebooks in the raffle at the end of the presentation if you stay tuned for that. And Pearson also sponsors physical computer books, and we'll figure out how to do those once we're back in person, which hopefully, who knows. As far as upcoming presentations go, you can check our meetup group and you'll see we have Graal VM for Java developers by Oleg from Oracle Labs. And this will be the first time we've actually had a current Oracle employee actually give a presentation for the group. We've been around since all the way back into Sun Microsystems, and this will actually be a first. And we've never had a Sun current employee, but I've been wanting a Graal VM presentation here for a long time, and we'll learn a lot about that. On March 11th, JFrog will be giving a presentation, Level Up Your Java Container Images. So it's okay, you can go ahead and RSVP for those meetings on our meetup site right now, and you'll be notified of those. So as far as those upcoming presentations, that meetup site, there's the URL, meetup.com/gatewayjug for updates to the presentation schedule and any location changes. If you're interested in giving a presentation or sponsoring the Jug, just send the steering committee an email with the bio and abstract to javasigsc@ociweb.com, and that will go to all of us on the steering committee so that we can see what we can do about getting you scheduled. So now we're ready for tonight's presentations, and this time we actually have 2 of them back to back. So the first one will be, they all have to do with Maven dependency management. The first will be surviving dependency hell with Maven, but Ray will give that. They're both from Google. And that'll be followed by Taming Dependency Conflicts for 70 Google Cloud Java client libraries by Stephanie. So what I'm going to do is I'm going to silence my microphone, and I believe you are a co-host, Ray. So why don't you take it from there?
Okay, yeah, I will do that. Thank you so much for having us here. Let me just make sure my screen is shared. And thanks for, again, attending this session. As like Bruce said, we will have 2 separate sessions. However, it will be about 30 minutes, 40 minutes each. They are closely related. In fact, I would say that the first half, which is my half, we're gonna go and explore many of the ways that you will go into a Maven Dependency Hell. And then Stephanie will show you how she has been able to tame 70 plus client libraries that she's managing and removing many dependency hells for our users. So I think those 2 sessions goes hand in hand, and I hope that you find this useful as well. My name is Ray. I'm a developer advocate for Google Cloud, and I focus exclusively on Java developer experiences at Google for Google Cloud. So if you ever tried GCP with Java, I think I may have a hand in there somewhere. If you like Spring Boot, I love Spring Boot, then you can try something called Spring Cloud GCP, which is something I helped start about 2 years ago. That being said, why am I talking about dependency hell? Well, because I also saw that our customers were having a lot of issues with our client libraries in the past with dependencies, and they were unable to use 2 or 3 different libraries together from us, and that really made us to think about how do we go ahead and manage our dependencies properly, right? And ultimately, Stephanie was able to solve a lot of these issues in the past year, thankfully, but this effort has been going on for a while. So one of the first things that we have done is to create jlbp.dev. This is a website. This stands for the Google Cloud Java Library Best Practices. And we're going to be talking a little bit about some of the practices there. But if you go to the website, you're going to see a whole list of practices that we now follow to avoid a lot of the dependency problems going forward. Okay. If you have any questions, you can find me on Twitter, which is @Satanism. I usually give this first part of the talk with Robert Scholte, who is the Apache Maven chair. And Robert has been awesome in helping me preparing this material. We usually do this talk together. Unfortunately, Robert is based in Netherlands, so it will be a ridiculous time for him. It will be very late for him, so he told me that he wasn't able to join. Now, unfortunately for me, for this talk, I usually just ask Robert all the questions about Maven, and I don't have to do anything because of that. But because he's not here today, I'll do my best to answer many of the questions as well. Okay, so let's see the code. We're gonna jump in straight into the demo of a very simple application. In fact, all I did is write a test. Okay, and this test is going to be using an old version of Google Cloud API client library. Why I say old is because we've been working on this problem for more than 2 years now, and I actually have to go back in time to find the libraries that had issues as we encountered them 2 years ago. Right, a lot of these issues are not an issue anymore, but so I had to go back in time and try to reproduce all the problems I ever had. So this is one of the first things that I was able to find, which is here. This only uses 2 libraries. We have a translation API. This is from Google Cloud. This is our ML API. And all I want is to translate from one language to another. Okay, that's what the API can do. And I'm going to assert the response to do a quick test and maybe print it out. Okay. And to do this, all I have is 2 different libraries. So I have the Google Cloud Translation API, and I'm using truth to do the assertions. All right. And as you can see in the IDE, everything compiles. There's no compilation error, right? Everything compiles just fine. Let me go ahead and clear really quickly and just say Maven compile. Okay. The reason I love Java is because it is statically typed, right? If it compiles, it should definitely just run, right? That's what I believe in. But however, in this case, let's go ahead and try it. I'm going to say Maven test, okay? And if it compiles, it should just run, but not this time, okay? Now, what happened here? If I scroll up a little bit, right, I'm seeing a test failure. How can that possibly be? This is so simple. there are only 5 lines of coding there, right? But then if I scroll up even a little bit more, I can see the actual failure. And the failure is actually a runtime failure. It's a no such method error, okay? And the no such method error, no such field error, no class def found error, if you're in the chat, feel free to, type in any questions. But in this case, let me know if you ever seen these errors before. I think a lot of Java developers probably have seen some of these error messages sometime in their professional Java career. And then it takes forever to troubleshoot some of these problems, okay? So these are the common issues that you're going to see. And the problem with some of these issues is that it doesn't happen at the compilation time. It only happens at the runtime, okay? And the core issue here is because, well, during the compilation time, maybe I'm referring to a class that actually has the method, but after compilation, after the class loading that's being done in your application, then it's actually loading a different class, is using a different dependency, okay? So that's where we actually run into a lot of these issues. And at the runtime, it's a lot harder to actually debug. So what happened here, and how do we actually know what dependency is potentially causing the issue, okay? And why does this actually happen? So one of the things that we can do is to go ahead and see our dependency tree. Okay, that's always the first thing that you want to do. Whenever that you have a dependency arrow like this, runtime arrow, that suspiciously look like a method should be there, but it's not there, it's usually a dependency problem. And you need to see the dependency tree always. Okay, that's the very first thing that everyone should do. There are 2 ways to see it. One way is to do this in the IDE. And in the IDE, if you want, you can go into the Maven tab here on IntelliJ if you win that license, and then you can say show dependency, okay? And it will actually show you a graph. Now, I like this graph a lot because you can see that even though I only had 2 dependencies in my pom.xml, you can see how deeply nested and how many more dependencies it actually pulled in. This is absolutely crazy, right? Just from 2 dependencies, and you have a whole forest of transitive dependencies. And this is where most of the dependency conflicts happened. And usually this happens when you have some transitive dependencies that is conflicting in version. And Maven has to choose just one version out of the many versions that you may have. In the graph here, I like to use this graph because you can see the red, okay? And the red is actually what IntelliJ is trying to tell you, that you have a dependency version problem. Like this particular dependency, this box right here, there are so many different colors to this because they are using different versions. Anyone have a guess of what that is? If you want to guess, you can type it in the chat. And if you have done a lot of Java within, say, Hadoop, or using like some of the data processing software, or just using Spring in the past, this is usually, and you may have guessed it, Guava, unfortunately. So if I zoom in a little bit and just scroll down here, you can see that all road led to Guava in this case. In fact, the easier way to figure this out is to say, hey, let's look at this no such error, no such method arrow, and you can see exactly which package and class this is causing the problem. And com.google.com base is in fact Guava. And we're going to talk about why this is happening in a second. But how can you do this without IDE? Well, you should see the dependency tree, right? So it's always good to see the dependency tree first. And you can use the Maven Dependency Plugin to do just that. And rather than having this nice graphic, you're going to see a text-based tree. And there's a lot of information in here. And from here, it's really hard to tell whether you have a dependency conflicts or not, because this is really a fully resolved tree. All the version selection has been done for you already. And one additional thing you might want to add is to turn verbose is equal to true, or just turn verbose on by specifying the flag. What this will then do is to show you not only the resolved version of the dependencies that you're using, but also additional information about why this version has been used. So for example, in this case, if I go to API comments, if I see Guava here, this library API comments depends on Guava 26.0, but it's being omitted for conflict with Guava 19. So essentially what that means is that it was supposed to use Guava 26, but for whatever reason, Maven has chosen Guava 19 to use. Okay, and if this tree is way too long, the other little trick you can use is to do include, right? So you can say include. So rather than seeing so many different lines, but you're only interested in Guava, you can include by the group ID or the artifact ID. So you can say includes com.google.guava. And what this will do is to show you the dependency tree with all of the transitive dependencies that uses Guava, like this, but also show you within context of the tree. And this is a lot better than what I used to do, which is to use a grep, right? So if you use a grep to see Guava usages, all you're going to see are the lines of Guava, but you don't actually see who's using it, right? Like this tree is completely nonsensical because you're only seeing any line with Guava. It doesn't have the context. So one of the first thing I learned from Robert is to use the includes declaration here, -d includes, and then give it the artifact that you want to question, and then it will show you the dependency information within the context of the parent and everything else. Okay. So now, why is 19 being selected? Like, what happened here? This dependency conflicts is very, very common. This is probably one of the most common dependency conflicts you're going to see. Basically, both Translate API, in this case, and Truth Client Library, they are all trying to use a version of Guava. They all have a transitive dependency on Guava. And one of them uses Guava 21, and the other one uses Guava 19. But Maven has to make the hard decision in terms of which version can this actually use. Now, why does it actually have to make that decision? Why doesn't it just use two versions at the same time? Well, it actually cannot, mostly because in the JVM, you cannot have duplicate classes. I mean, even if you do, then it's going to traverse your class path, and the first class it sees is going to win. So even when you're running your application in the JVM, if you have duplicate classes like this, it can only use one. So there's no reason for Maven to put both of the versions into your class path. And so Maven have to pick one. And the way that Maven has been designed to pick the dependency in this case is to pick the nearest one. So if you go back to the dependency tree, right, this tree is pretty deeply nested. So the one that's the nearest to the top of the tree will be chosen. So in this case, truth was declared first, and truth has the dependency on Guava. And because this is first and it's also the nearest, this version has been selected and overwriting all of these other versions that could have been better. Okay, and this is why you run into many of these type of dependency problems, especially when you have version disagreements around your transitive dependencies. And Maven can only choose one version, and it chooses the nearest version, not the highest, and because it doesn't actually understand your versioning scheme for the most part. Maven does not understand semantic versioning. A lot of people may say, why doesn't Maven just pick the highest version? Why doesn't it just pick the most compatible version? Well, Maven actually does not understand semver. The version field in Maven is just a text. It doesn't understand the meaning of it. But even if it did, the libraries may not actually be compatible anyways, because library creators, when they change the version, may actually make backwards incompatible changes. So it's meaningless for Maven to be able to make that choice because the library itself could be broken. So it's doing some of the simplest thing possible by choosing the nearest one. To avoid this problem during the runtime, though, we can actually check for these version disagreements by using the enforcer rule. I don't know if anyone here has been using enforcer rules. This is one of the best plugin that you can add to your, I think, to your Maven build file to improve the health of your build and also to make sure that you're using the dependency version that you want to use. So what does the enforcer do? The enforcer will, at the compilation time, perform a number of checks, and there are many, many different types of checks, and they are known as the enforcer rules. And there are some rules around dependency versions. There's a rule to say, hey, I want to make sure that all of the transitive dependencies, all of the dependency versions match exactly the same. And to do that, you can use the dependency convergence rule, okay? So for example, this is a very, very stringent rule. It's not easy to implement, but let's give it a try. So in my application, I'm going to go to the pom.xml, And I'm going to go to build and add a new plugin here and just pasting the Maven enforcer rule. Okay. And what this is going to do is to say, hey, I need to make sure that all of the Guava versions across the board has to agree. I don't care what it is now, but they all have to agree. And now if I try to run the test, it's going to try to compile first. It's going to run the enforcer rule. And before we can even compile, it's going to tell you that the enforcer rule has failed. And it's going to tell you all the libraries, every single one of them, that is disagreeing in terms of versions. Okay, and you can see there's a lot of these dependencies that you have to pick a version, like this one. Google.com Protos, right? This one is using 1.12, and this one wants to use 1.15, and this one is trying to use 1.16. Which one should we be using, right? Maven does not know. You have to make that choice. Convergence is really, really hard, mostly because there will be infinite, a lot of like combinations of conflicts that you're going to have. So in some cases, especially in end user application, sometimes you may just want to use the highest version, right? Because usually the newest version may be compatible with the lower version. Maybe, not guaranteed, but maybe. So in that case, what you may want to use is to use the upper bound rule. Upper bound, if I can see it. No, I don't have it in this. But let me see if I can find an example of this. So rather than using dependency convergence in your application, it might be suffice to say that you just need to use the highest version. And this will then check this is less stringent. And you'll just make sure that whatever is in your dependency tree, whatever dependency has been selected, is the highest version instead. So I'm going to copy that over and just replace dependency convergence with upper bound and do another test. And now I think my failure should be, well, still a lot, but you can see here, right, Guava, it should be using 26 rather than 19. And now you can see the upper bound check is failing. And this will definitely help you to avoid running into dependency issues at the runtime. However, like I said earlier, using the newest version doesn't always guarantee it's going to work. Why? Because the newest version may actually have backwards compatible changes. If you upgrade it from, say, OKHTTP 2 to OKHTTP 3, right? If they didn't do something smart with the way that they have repackaged their stuff, Maven will think that 3 is higher than 2, and so 3 will be used, and it's going to break all the APIs that you ever use with 2, right? So you cannot always use the newest version. So here we have some JLBP rules. Number 1, as a library maintainer and creator, JLBP 7 says we need to make sure that the transition to new version is easy. Do not break your new version. Do not break those APIs. And JLBP rule number 10 says, well, if you absolutely have to break, well, you have to plan for it, but you want to maintain API stability as long as needed, okay, for the customer. And we actually took that to heart. A lot of people have dependency issues with Guava because Guava is always doing a major version update. There's always backwards incompatible changes. However, starting from Guava 21, because we realize how critical Guava is in everyone's Java code, starting from Guava 21, they're all backwards compatible. Okay, so if you are not using Guava 21, you should at least upgrade to Guava 21, and anything above it will be backwards compatible with each other. Okay. Now, if the upper version is in fact breaking the lower version, like say you are using Hadoop, you're running a MapReduce job, Hadoop has a very, very old version of Guava in their system class path. And if you try to use any of our client libraries, which depends on newer version of Guava, it's going to break because you can't like override that system class path. Or if you just need to use the newer version of Guava and you have code that depends on older version of Guava, they're also going to break. You have to update the code, or you have to use both versions of Guava simultaneously. And the only way to do that is either you have to fix the class loader, like Hadoop should really fix the class loader and make sure that the MapReduce job is running within its own class loader, or using OSGI. I don't know the audience here, but I rarely hear anyone using OSGI. I definitely do not use OSGI myself. I don't want to touch it myself. And finally, the other way is to shade. So you can shade a newer version of Guava into your own jar But when you do that, you have to relocate it. You have to make sure it's using a different package. Okay, so that otherwise you still will have multiple versions of Guava sharing the same file names and the path. So to avoid it, you have to relocate it to a different package. Okay. I think I saw someone asking a question here. One dependency may require an older version. Yeah, a newer version. Yeah, exactly. Yeah. So I think I may have answered that question. All right. Now, how do I actually reconcile my dependency tree so that I can pass my upper bound or convergence test? So to do that, we have to go back to the tree and clean it up. We have to exclude things that we don't want. We have to exclude versions that we don't want, or we have to use dependency management. So there are two different ways of doing this, right? I'll just show you a very quick example of this. So to exclude, basically, in this particular example, maybe I want to exclude the version of Guava that is coming from truth, then I will have to do the exclusion here. Exclusion has its own problems, as you can see. The more dependency conflicts you have, the more exclusions you will have. And eventually this becomes completely unmanageable. The other thing is that exclusion doesn't matter whether the the parent actually depend on this this library. So for example, if a newer version of truth doesn't depend on Guava anymore, this exclusion would still be there. It's ineffective, but in fact, you will have useless code, in this case, useless XML. And if you don't clean this up, this will become very unmanageable. The better way of doing this is by using dependency management. So what is dependency management in Maven and how do you use it? Dependency management is a special section in the pom.xml. It is not the dependencies section, it's a dependency management section, okay? And in this section, you can specify the dependency here. And what I learned from Robert is that this is really just a key value pair. This is really just a lookup table. It's a lookup table by the group ID and artifact ID. So you can list whatever dependencies you want here. They are not real dependencies. They're not dependencies until you add it to the dependencies block. However, it is a lookup table. What that means is that anytime, for example, that Maven comes across a transitive dependency or direct dependency that's using Guava, matched by group ID and artifact ID, it's going to come to this lookup table and say, aha, I need to use version 28.1. Okay, so it overwrites any version that you selected within the pom.xml. The dependency management section will override any other version that you have selected. Okay, so this is a very, very powerful tool to help you ensure that you're using certain version of your dependency. So let's go ahead and just show you what this looks like. I'm going to say 3B, that management. And I'm going to go ahead and do a dependency tree. So very, very useful. Dependency, if I can only spell dependency tree, deverbose, and includes, I'm going to see Guava again, google.guava. Okay. Remember, this is going to show you the tree with Guava in context. And now, rather than having the version being overwritten by something that's nearest in your dependency tree, it's now overwritten by the dependency management section. Okay, so here we can see clearly that all the Guava version has been updated to 28.1 across the board, and the version is being managed from the dependency management section. So whatever that you specified previously do not apply anymore. And this is a very, very powerful tool to override dependency versions. Okay. So 2 things so far: the enforcer rule, and second part is the dependency management section. Let's take a look at example 3E, and just be conscious of the time. I think I have maybe 10, 20, 15 more minutes. Okay. So I'm going to see 3E here. So in this example, it's another test I'm going to run. And in this pom.xml, I learned my lesson. So I have my plugin for the enforcer rule. I'm using require upper bound checks. I'm managing my dependencies using the dependency management section, right? So everything should be passing. I'm using like 2 different client libraries again. I'm using Firebase and Google Cloud PubSub. PubSub is just a messaging system on Google Cloud that you don't have to manage, which is really nice. But let's go ahead and try this out. So this is example 3E, clash. I'm going to compile, right? It's going to run the enforcer rule. And I can see that not only did it compile, but all the rule had passed, right? So now let's go ahead and run the test again. Assuming that the best practice that we applied was good, but unfortunately, it failed again, okay? And unfortunately, it failed again on Guava. Shoot, it's always Guava for some reason. If I scroll up a little bit more, you can see, oh man, there's no such method error. So it's again a dependency conflict. Now, why did this happen now? I follow all the best practices we talk about so far. What happened? Now, this one was particularly hard to find out because if I see the dependency tree for Guava, I'm going to see that all the Guava versions are being upgraded to 28.1 because I'm using dependency management. However, there was a really obscure and really hard to find issue, which is that there's a Guava-JDK5 in the dependency tree. Now, this was a very bad practice on Guava's part, I have to say, because it released the same library with the same classes under two different artifacts. And that's a huge no-no because Maven not only doesn't understand Sanford, when he sees that there are two different artifact IDs, Guava-JDK5 versus Guava, they assume they're very two different libraries. And so they cannot reconcile in terms of version. And what happened then is two Guava classes got onto the class path. And remember, the first one wins in this case when the JVM resolves the classes and it's going to see the wrong classes. Okay, so basically what happened is that both of these versions made it, and one of them is version 28, and one of them is version 17. And that is pretty bad, right? And so what we need to do is to ban some of these duplicate classes. We need to be able to find these issues early so you don't see this during the runtime. It's absolutely annoying if you see this during the runtime. It's just so hard to troubleshoot. So you want to capture these issues upfront and early. So we have another enforcer rule called ban duplicate classes. Okay, this is the ultimate tool where you can say, in case that some library practices this a bad practice, then you can still find it. So how does this actually work? This is an additional rule that you can add to the enforcer. Okay, and this is actually stored in the extra enforcer rules package. So you actually have to add this as an extra dependency for your enforcer rule. Okay, and then I can go ahead and add the ban duplicate classes section here. Okay, and I'm just going to add it, I think here. And you can, of course, ignore some classes if you want to, but I'm just going to get rid of that. And then I'm going to run this test again. And now this enforcer rule will take place. And now you can see the enforcer rule fail. And look at all these classes that's actually being duplicated across multiple artifacts. This is absolutely horrible, right? And however, the enforcer rule will tell you that, hey, these classes were found in these two different artifacts, and you should definitely get rid of one of them, okay? So that's the other enforcer rule that could be useful for you, okay? So we have two more JLPP rules. Number 5, which is that dependencies should not have overlapping classes with each other, obviously. So Guava and Guava JDK5, they should not have overlapping classes. And this is also why sometimes when you upgrade a new library to a major version, the library maintainer actually chooses to change the package name. Like from OKHTTP2 to OKHTTP3, the package name is actually changed, and also the artifact ID is changed too, or the group ID is changed. I do that in my own library as well. The other thing, and this is more relevant to JPMS, if you're using Java 11, Java 9 and up, and you have Java module system, with modules, you can only have one package within the module anyways. So you should definitely follow these best practices, okay? Let's see. Yep, I talk about this one too. So actually, let me click into this, right? This is like when you're releasing a new major update of your library, you should consider changing the package name. And also when you do that, you should always change the artifact name as well, okay? By the way, this is the GLBP website, and this is where we write about one of the rules. We have really detailed descriptions of why things are happening and why we want to avoid it. And then also we have the recommendation that the library maintainer should follow, okay? and it's pretty long. And then at the bottom, we also have some examples of people following these best practices. So for example, when JDOM moved from version 1 to version 2, it was org.jdom, and then they changed the group name to and package name to org.jdom2. Same thing for my own library, and same thing with Apache Commons, right? And this is so you can avoid the issue that you saw in Guava earlier. Okay. We also have another rule that says keep your dependency up to date. Always try to use the newest version. There's no reason why anyone should be using Guava JDK 5. I understand it's hard, right? I deal with enterprise software all the time, and there are some really old versions everywhere. Do your best whenever you can to update the versions. All right, so let's see one more example. I want to be conscious of the time. 3C. So this is let me see here, example 3C. This one is also really interesting problem. Okay. I'm going to go ahead and run this example right now. Example 3C. I'm going to do a test. And I think I have the universal rules. I'm using the best practices everywhere, just like before. And I think it's going to say that it failed. It's telling me that, hey, look, your gRPC stop version is outdated. You should be using 1.10. That's the upper bound check. You're currently using 1.0.1 selected by Maven. So how do we fix it? We go to the dependency management section, and we specify the gRPC stop version we want to use, right? And now if I run the test again, or the compile again, everything will pass because now I'm selecting the right upper bound version. However, not surprising to you, the test fails again. And this time, it's not Guava anymore. This is actually gRPC, okay? Now, we will go through the standard troubleshooting procedure. Let's see the dependency tree. In this case, we're going to see io.grpc as the group ID, right? And all you're looking for is version incompatibilities, okay? And this one was also particularly hard because here we can see gRPC protobuf 1.10.1, and then there's gRPC core 1.0.1. You can see there are huge version differences here. In this case, gRPC as a whole is composed of multiple gRPC modules. And these modules have to work together, and so they are tightly coupled together. And if the versions are not aligned between these modules, they cannot operate with each other, and that's why we saw that dependency conflict again. Even though all the upper bound rules has passed, but there's additional requirement that these libraries has to be the same, right? The same version, okay? And this is what we call version misalignment. This can happen especially with Netty. Netty has different modules, and you have to make sure all of their modules are using the same version or compatible versions. Otherwise, Netty will fail. The same thing happened with gRPC here as well. So to do this, you can use the dependency management section, but you can also extract the dependency management section and put it into a dedicated POM file. And now this POM becomes a BOM, a bill of material. And the bill of material can override all of these dependency versions for you automatically. So rather than encoding everything into your own app, you can depend on an external BOM. Okay, so I'm going to show you what this looks like. So for gRPC on Maven, this is a BOM that has a POM.xml that only has the dependency management section. In this dependency management section, it has all of its own submodules with the compatible versions that it wants to lock in. So here we have all these gRPC modules, and they all have the same version. And by importing this BOM, you can overwrite all of the gRPC module versions in one shot. Okay, so to show you this one last example here. So here we have the gRPC dependency management version, not this one, sorry, this one instead. So to use the gRPC BOM, we can set the scope to import, and the type is POM. And this will then instruct Maven to read this dependency management section into your own Maven POM.xml as if you wrote it yourself. And then it will use it to override all of the subversions, okay? However, it has a lot more issues than what I'm going to describe just now. But this is one of the best practices, which is that if you have tightly coupled multi-module projects, you should always produce a BOM. Okay. Now, there's a lot of problem with the BOM though. First of all, BOM will override any versions in the transitive dependency tree. So your BOM should only include modules within your multi-module project. So for example, if gRPC is using Guava, it should not add Guava into it because then you will override your version of Guava too. It should only include its own module. And it has a much bigger issue with dependency management. And this is the fundamental issue that causes a lot of pain in our client libraries. And that's what Stephanie will talk about next. Okay. So before I close, I just want to show you one more thing, which is the linkage checker. If you ever want to find these missing dependencies, you can run a static analysis on this. And Google has produced an enforcer rule called the linkage checker to do just that. Right. So if all things fails, you can run the static checker before you even run your app. Just to recap, in your POM, make sure you try to use the enforcer rules. If all things fails, use the linkage checker, and then follow the JLBP best practices and use the dependency management section to set your versions. However, that will only solve half of the problem, and Stephanie will talk about the other half of the problem and how she actually fixed our client libraries. Okay, so I'm going to stop share and let Stephanie take over. And we'll get to all the questions in the end.
Okay, great. So while I transition, there is one question in the chat, right, that someone asked about how does dependency management enforcer rule work in Gradle? If you want to answer that while I just pull out the presentation.
Okay. Actually, as you know, as you've seen, I actually don't use I actually don't use Gradle so much. However, let me see. I think this question did come up in the past with Robert too, and I don't remember the answer, to be honest. I think Gradle has their own plugin to do some of these enforcement, but it's definitely not the same as the Maven enforcer rules. Let me see if I can find some example of this online. That being said, my good friend Andres Amire, I don't know if you know him. Andres Amire, he was really into Gradle. He also loves Maven. We used to do this talk together as well. And he has a project called Core Dump, KORDAMP. And apparently Core Dump can actually hook into the enforcer rules from Gradle. So I'm gonna paste the stuff here and you can take a quick look. All right, nice.
Awesome, great. So I am sharing my screen. Is my screen visible to everyone?
Yep.
Okay, awesome. So thank you very much, Ray. I will take it from here. So I guess Ray summarized different types of issues you would see in Maven dependency management, the common types of errors, how to tackle them, and how to prevent them from happening. We applied those kind of methodologies and rules directly in our Java dependency management in Google Cloud. So today I will be talking about some of the strategies that we adopted in order to tame our dependencies across our 70+ GCP client libraries. So a quick introduction to myself. My name is Stephanie Wang. I am a developer programs engineer working at Google. I joined Google about a year and a half ago. And prior to joining Google, I was a software engineer at Morgan Stanley. I worked on sales and trading applications for about 3.5 years and then came over to Google. And my main responsibilities now is to manage our Java BigQuery client libraries. I implement new features and I implement bug fixes in our client libraries. And I also manage dependencies for all our GCP client libraries. I am also on Twitter at Steph Wang Builds, and you can also check out my website that's hosted on GitHub. Great. Before I jump in further, you may be wondering, what are client libraries? So just a quick overview, the Google Cloud client libraries are our latest and recommended client libraries, or say ways or methods SDKs for calling the Google Cloud APIs. The reason why most of our enterprise customers interact with Google Cloud APIs through our client libraries is because we provide this optimized developer experience by giving the developers the supported language language's natural conventions and styles. In other words, the client libraries are written in idiomatic ways. So we have generated and also handwritten code in each language, and the languages include Java, Python, C++, Go, Node.js. So these are the silver languages that we support, and we make the Google Cloud API more simple and intuitive to use. And they also handle the low-level details of communication with the server. BigQuery, for example, we have the HTTP layer, and the client library handles a lot of the transport layer construction. If you're interested in learning more about the Google Cloud Client libraries, please feel free to check it out more. I have a link over here. So like I said, we have lots of client libraries, and dependency management has slowly become quite a challenge for us, especially in the Java space. So just want to share a little bit of the real Java maintainers of our 70+ GCP client libraries. When you have a large number of Java client libraries like we do, 70-something, dependency conflicts happened all the time. So here is a little snippet of an example of a dependency conflict that happened when we're trying to upgrade our own client library in another client library. So GCS stands for Google Cloud Storage, and BigQuery is obviously the Google Cloud product. So basically, BigQuery is pulling in GCS as an artifact, as a dependency for some of the functionalities. Right, so when we're trying to upgrade the GCS version in BigQuery, we faced this upper bound dependency error because Google Cloud BigQuery depended on Google Cloud Java Core artifact, which pulls in protobuf Java, and it also depends on Google Cloud Storage, which pulls in protobuf Java as well. But you can see that Google Cloud Storage had an older version of protobuf Java. However, Google Cloud Core, which already exists in Google Cloud BigQuery, has a different version, 3.11.3 over here. Thus, we have a dependency conflict. Similar issue happened with the Google Cloud Core HTTP artifact. So it is pulling in open census 0.24.0, but cloud storage is pulling in 0.25.0. So yet another dependency conflict. So we had lots of troubles even updating dependencies that we owned, that Google were depending on each other. And another issue that we had was we had a huge number of dependency update PRs. And the reason for that is because every single client library managed their own dependencies individually. So between January to March 2020, we had 104 dependency update PRs alone in the Google Cloud BigQuery Java client library. So this is a quick screenshot I took, and this is my face for a lot of those days. It was extremely frustrating, and BigQuery, we have 5 different client libraries, and you can imagine this multiplied by 5, and also if you consider other Java client library maintainers, that's just a huge volume of dependency updates that we needed to update. So to understand our problem, it would be really nice, I thought, that if we could reduce the number of dependency update PRs that came into our open source client libraries. And it would also be very nice if you could reduce the upper bound dependency errors that occurred during our dependency updates. So what that means is we probably should consider to stop managing common dependencies individually in each client library. And also, on top of that, we should consider to start using consistent versions of the same dependencies. So if both Google Cloud BigQuery and Google Cloud Storage are depending on Google Cloud Core, for example, then that Google Cloud Core version should just be the same for both of the artifacts. So ideally, we should be able to bundle up all the common dependencies to manage their versions at one place centrally, and also pull the commonly managed dependency versions easily into each client library. So how do we achieve this purpose? Well, so I guess if you paid attention to Ray's presentation earlier, you probably will be thinking the BOM. And that's exactly what we did. So we built and released the Google Cloud Shared Dependencies BOM in order to handle this exact scenario. And just to refresh our memory, the BOM is a special POM file that Maven uses to allow us to define the versions of our dependencies. And that could be direct or transitive. So it is a special type of POM file where we declare the versions and also the scopes. In other words, it's a centralized place for us to mention all the dependency details. And relate back to JLBP, JLBP number 15 states that we should be publishing a BOM for the multi-module projects. And importing the BOM means dependency versions from the BOM will be used. So this is really how we applied the JLBP in theory, kind of in real life. So what we did is that we summarized and bundled up all the common dependencies used across our GCP client libraries. And these are the yellow boxes over here. And you can see we have dependencies such as gRPC, GAX, GAX gRPC, Guava, Protobuf API Common, JSON, Google Cloud Core, etc., etc. Right, so we bundle all of these dependencies up into our Google Cloud Shared Dependencies BOM. And then each client library, each API-specific client library is importing this Google Cloud Shared Dependencies BOM. So in other words, every client library now will be using the same version of the dependencies, right? These dependencies. So as a result, we no longer had any upper bound dependency update errors when we tried updating two client libraries that share the same dependencies. And also, the number of dependency updates reduced significantly from 104 in Q1 2020 to only 31 in Q3 2020. So that was very nice for us. Okay. However, right, BOM is only part of the solution. It could also introduce new problems, right? So here is a scenario that I would like us to kind of imagine. So suppose we have the PubSub client library that we're trying to manage, right? And it's pulling in direct dependencies, GAX, gRPC, and Open Census, which brings in other gRPC dependencies. And as you can see, there could be a version misalignment where the GAX gRPC on the left-hand side is pulling in older version of the gRPC artifacts. However, Open Census on the right-hand side is pulling in a newer version of the gRPC artifact. So there is obviously version misalignment, thus potential dependency conflicts introduced, right? So, one way to, for us as client library maintainers to address this problem within our client library dependency management is for us to import the gRPC BOM, right? So we can easily just import gRPC BOM version 1.10.1 in order to manage the versions of these gRPC artifacts that are in our tree. So now everybody should be 1.10.1. Great. However, if you think about if the user's application wants to use our PubSub client library, now which version of gRPC do you think is being used by the user's app? And I welcome you to type your answer in the chat if you want to. Okay, just gonna pause for a moment for people to think about what version of gRPC do we think our users will be using. 1.10, yeah. So I'm gonna answer saying 1.10.1. Okay, great. Yes, actually, most people would think that it will be 1.10.1 because see that we are managing gRPC version by importing the gRPC BOM in the client library. So naturally, user app should be getting 1.10.1, right? No, this is actually incorrect. The user actually would be getting still 1.0.1 on the left-hand side and 1.10.1 on the right-hand side in the user app. And this is an issue that is very insidious that we've seen in past customer issues, and a lot of people are still very much unaware of. And we coined the term as the loss of transitive dependency version, right? So the only way really, I mean, there are two different ways for us to handle this issue. One of the ways that's, I guess, more immediate is the user will have to also import the gRPC BOM in order to manage the versions of gRPC artifacts over here, right? So for them to do that, they would first have to figure out what version of gRPC we're actually using in our client libraries, right? By inspecting our client library BOM. And then they will be able to go find the correct version of gRPC BOM and then put that in their POM file. So it's a very troublesome way and lots of burden on our users app in order to align these versions, right? Alternatively, and this is what we decided to do, is to lock the versions in by using this open source Maven plugin called the Maven Flatten Plugin. So what the Maven Flatten Plugin does is it encodes the version specified by the BOM into the pom.xml, and then gets it published to Maven Central. So essentially, you would have a natural pom.xml in your client library, for example, and then we flatten this pom.xml into the flattened POM, and then we publish the flattened pom.xml to Maven Central. And here is an example of the flattened pom.xml that I published onto Maven Central for the Google Cloud BigQuery artifact. So essentially, you can see we have these exclusions here, and then we have every single dependency. So we have a much bigger pom.xml file as a result, because we are flattening every single dependency that is used in this client library. And we're also making sure that we're locking in the version while we flatten, right? So I guess a more visual way to understand this is that now, right, the pub/sub library would no longer have that nested tree structure in the POM file, and instead it's going to be flat, and it will be pulling in all these versions directly. And the versions will be locked in so that the user app will be absolutely getting this 1.10.1. And this is so important for us because we are building and testing our client libraries with the 1.10.1 version. So the fact that the users could be using it with 1.0.1 version of gRPC means that we could introduce problems for our users. This is aside from having dependency conflicts, right? However, we're aware that such kind of transformation could have issues. For example, so since we're flattening our pom.xml file, we want to make sure that we're not altering our original POM. So POM correctness and completeness is so important to us. So we want to make sure that we check for the resolution order, and we also check for runtime dependency, whether they're correctly resolved. So that is why we decided to add a pre-submit check for every single client library to just make sure that we're not altering our POM file while we transform our POM file from the original to the flattened, right? So now this is the new scenario that our users are now using, right? So the users app could be trying to use pub/sub library and BigQuery library. And both of these client libraries are pulling in our shared dependencies BOM that contains all the commonly used dependencies. And they're importing this BOM so that they can manage the versions, so that they can use the dependencies that are being managed by the shared dependencies BOM. And they could also be importing some other dependencies, right? And we are confident that our users are getting access to the dependency versions that we think we are supplying them with, because our client libraries are now flattened. So this really does not just help us as library maintainers to make sure that we are able to provide naturally compatible client libraries. In addition to that, it also helps us solve customer issues, right? So actually just this week, I had to handle a security vulnerability. And this CVE was introduced due to an older version of Commons codec, which is an encoder-decoder dependency. So here is a little bit more description of what this vulnerability is. But essentially what happened here is that the Google Cloud BigQuery artifact depends on the Google HTTP client artifact, which depends on the Apache HTTP client artifact, which then pulls in this bad version of Commons codec, right? So one person suggested that we could try to manage the version of Commons codec in the dependency management section of Google HTTP client artifact, because this is the artifact that we have control over and we can release and update. So a PR was made against this, right? So you can see what they're trying to do here. If I make it a little bit bigger, is that they added the Commons codec artifact into the dependency management section 1.15 of this Google HTTP Java client repo, this artifact, right? However, this was not going to work. Why? Because the Google HTTP Java client is not flattened, which means this version of Commons codec was never going to get to our users' hands. They were still going to get 1.11. So the correct way for us to address this, and the way that we went with, was to manage the version of this artifact in our Google Cloud Shared Dependency spawn. And that's what I did, which is to add in the artifact Commons codec to the dependency management section of the Google Cloud Shared Dependency spawn. And now remember that we are flattening our Google Cloud BigQuery client library. So that is how we made sure that our customers are going to be seeing 1.15 in their dependency tree. So in other words, the Google Cloud Shared Dependency spawn plus the flattened client library gave us a solution. So we no longer have this problem. So as you can see, this not really just help us as library maintainers to simplify our life, to make our client libraries more compatible, but in the meantime, it does help address actual customer issues as well, right? And on a grander scale, what does this all mean for our client library consumers, our actual users, right? So suppose if a customer, or say a library consumer, wants to use the BigQuery data transfer client library and the PubSub client library to schedule data transfer jobs with real-time PubSub notifications. Now, how do they ensure that the two client libraries are actually compatible with each other? The solution one is going to be the one that we talked about before. So the customer could directly apply the Google Cloud BOM. So the BOM will then directly manage the version of the dependencies that the customers have, as long as they import the BOM in their dependency management section. However, this is not an option that all of our customers have. Some of our customers, or your customers, could be resistant against using the BOM solution. Maybe they want to continue managing their own versions, or maybe they're using SBT, which forbid them from being able to use the BOM strategy. So in that case, we decided to build this Google Cloud BOM dashboard to help our customers find out what versions of the client libraries are compatible, right? So here is a real scenario that we faced. A GCP customer wanted to upgrade the Google Cloud BigQuery artifact to version 1.124.5 from 1.92.0. So you can see it was quite a major upgrade. And they had quite early versions of all the other Google Cloud artifacts, right? So they were relying on a number of GCP dependencies, and they were unable to just upgrade the BigQuery artifact because these dependencies shared the same transitive dependencies that had dependency conflicts. So they needed to upgrade all the other dependencies to certain other versions so that everything would work compatibly together. So now the question they posed to us was, how do we resolve this issue? So my first answer to them is for them to try to use the BOM strategy, because that was the easiest and simplest way, right? You can simply use the BOM and we manage the versions for you. But they said no, they didn't want to go with that route. They wanted to continue managing their own dependencies, and they want to stay flexible in dependency management. So fine, how do we then help them to find out compatible versions of the client libraries that 100% would not introduce any dependency conflicts? And that's where the Google Cloud BOM dashboard came into rescue, right? So all we had to do is to open up this dashboard, and we have this all versions page that pull up all the Google Cloud Java client library versions and artifacts, right, that exist in different versions of the Google Cloud BOM. And we simply search up the version 1.124.5, right? If you just do 1.124.5, so this allows you to pull up our Google Cloud BigQuery artifact over here, and we see that the underlying version of Google Cloud Shared Dependency Spawn being used is 0.15.0, which means that all these other artifacts that our user was dependent on, right, Bigtable, PubSub Spanner, as long as they were using also the Shared Dependency Spawn version 0.15.0, there would be absolutely no dependency conflict. They would be naturally compatible. So all we have to do now is to use this version of the Google Cloud Shared Dependency Spawn, and we do a simple search and then locate the versions of the client libraries that would share the same version of Google Cloud Shared Dependency Spawn, right? And that led us to locating Bigtable version 1.18.0, PubSub 1.109.0, etc., etc. And we're able to address this customer issue very efficiently without having them compromise and migrate to the BOM strategy. So here is a blog post that I wrote with Ray's help on debugging the Maven Flatten plugin in IntelliJ. If you're interested in learning more about the Maven Flatten plugin and how to debug it, and if you're considering maybe adopting it in your own project as well, I welcome you to just check it out. Other than that, I think that's pretty much it. And yeah, that's it. Thank you.
Right, and I think there are some questions in the chat, just looking over it. One of them is, I think there were still some questions about whether the BOM import was correct, like why wasn't it carried over? If you don't mind, if you can go back to that slide where you have the user app versus, I think maybe that requires just a little bit more clarification. Yeah. That one, yeah, the other one, yeah, there you go. So I guess I'll also just jump in here as well. So in this case, the user's app will see the PubSub library. So even though PubSub library is importing the BOM to override the versions, the user's app does not import the BOM, and so it does not actually import the gRPC BOM transitively. So what it's going to see is the PubSub library. And then PubSub library will depend on that version of GAX gRPC, and it will depend on the wrong version of gRPC modules in that case. And I think that's where Stephanie coined this really well. It's called the, yeah, there you go, loss of transitive dependency version.
And I definitely encourage you to try it out. You can easily build a simple kind of a sample project or test project to see this example. Actually, Ray, you may already have this example in one of your demos. I don't know if you still have that, but this can be easily proven actually.
Yeah, and it's such a what do you call it? Gnarly, a weird issue that a lot of people don't see it. It took me a long time as well. It took us a long time to figure out, oh my God, that is the problem. Like that's the root of all evil in this case. Like when everything compiled fine, but when the user uses it, it's still broken. And that was the real issue back there.
Right.
Yeah.
So the question here, okay, so I see a question over here. The BOM import is still being used. But isn't it the purpose of the BOM? Yes, the purpose of the BOM is to manage the versions in your project. However, notice the difference between user apps access to the artifact versions versus the client libraries access to the artifact version. So there is a key difference over there. So the BOM that the client library was using, the gRPC BOM, was unable to actually transitively, I guess, call this transitively manage the artifact version for the user's app. And it is so common that there were engineers who are making pull requests thinking it was going to work in the dependency management section without flattening. And it's dangerous to do that without flattening. That's the whole point.
Yeah. Another question, do you have nested BOMs as well?
I do not. Yes, actually, yes, we do. We do have nested BOM, and I will share one example right now, and that's in our Google Cloud Shared Dependencies BOM. So let me just pull up the Shared Dependencies BOM. So what we're doing over here, when we built the Google Cloud Shared Dependencies BOM, we actually intentionally imported other available existing BOMs. I believe we're importing the gRPC BOM over here. Yep, that is the case. And we're importing the GAX BOM, the Guava BOM, etc., Protobuf BOM. I don't think we're importing OpenCensus BOM. We're importing a number of BOMs over here. So I guess we'll call this nested BOM, if that's the question. Okay. How do things change when your dependencies are JPMs, modules on the module path, rather than traditional jar files on the class path? Now, this is something I am not familiar with.
So I think I'll probably take this one as well. How do things change if your dependencies are GPMS modules? Let me think here. So as far as I know, the module system also cannot have multiple modules of different versions, right? You cannot have the same module of different versions, so you're gonna run into the same issue. The GPMS, unfortunately, is not like OSGI, so you can't have the same module of two different versions running simultaneously with each other. So in that case, I guess you are gonna be stuck with, making sure that you choose just one in most cases. Yeah, that's as far as I can see. And also based on the GLPP rules, so the other rules is that the different modules cannot have overlapping package names either. So these modules have to have different package names. So it's possible to have two different major versions of the same library, but as long as your artifact ID is different within Maven, and also their package names are physically different, so that their classes are not overlapping each other.
Yeah. Okay, thank you, Ray. Yeah, I think, overall, I guess we just really wanted to share this very insidious, subtle problem that truly is still confusing lots of engineers with all of you, and kind of share our lessons that we learned through implementation in our Google Cloud open source client libraries. And I hope that was a helpful presentation. Maybe could inspire you to do some experimentation on your own. And please do let us know if you have questions, follow-ups. We are on Twitter, and reach out anytime.
Okay, well, thank you for a great presentation. Normally at this time, we'd probably have a big round of applause here for both of you. I don't know if people would type that into the chat or anything like that. Thank you. So.